All right, welcome back everyone. This is another explainer brought to you by Forge College. So in our last session together, writing base and derived contracts, we really got our hands dirty with the basics of overriding functions. And honestly, you all did great. But today, today we actually have a bit of an engineering mystery on our hands. We're jumping back into the Solidity from Zero track to look at a pretty notorious suspect when it comes to smart contract bugs, and that is multiple inheritance. Specifically, we are exploring using super and inheritance linearization. And look, I know, linearization sounds like some made-up word a sci-fi villain uses right before firing a laser beam, but I promise you, it's actually going to become your best friend. Okay, let's dive right into this.
So think of me as your senior engineer today. Here is our blueprint. 1. The multi-inheritance mystery. 2. Meet C3 linearization. 3. Super, the baton pass. 4. Fixing the broken chain. And 5. Constructors follow rules 2. Let's head straight to the scene of the crime.
Section 1. The multi-inheritance mystery.
Okay, so every good mystery starts with a faulty schematic, right? We're going to look at a smart contract aptly named app. Now, app is a busy contract because it needs to inherit from two entirely different parent contracts, logger A and logger B. It is your classic multiple inheritance scenario. We basically want app to inherit the initialization logic from both of these parents. Sounds super simple, right? Just tell both parents to do their jobs. Our intended behavior was that both logger A and logger B would run their init functions and emit their logs. But if you look at the actual behavior, only logger A initializes. Logger B is completely silent. It's literally like we hired 2 employees and only one actually bothered to clock in for the shift.
So the absolutely crucial question here is why? Why did only logger A's event fire? Well, if we were to peek at the buggy code, we'd see that inside the app contract's init function, the developer explicitly wrote logger_a.init. They literally hard-coded the call to one specific parent, and they completely ghosted logger B. Now, this is a very, very common beginner mistake. But to really understand why this breaks things so badly, we have to look at the machinery operating under the hood of Solidity. Which brings us to Section 2, Meet C3 linearization.
So, C3 linearization, this is essentially Solidity's method resolution order. I want you to think of a complex family tree with branches going off everywhere. Solidity acts kind of like a really strict factory manager here. It looks at that messy, branching family tree of inherited contracts, and it forcefully flattens it into a neat, single file line. It creates one perfectly predictable sequence. There's no branching, there's no parallel execution, just one straight line.
Let's actually look at the exact linearized chain for our buggy app contract. When you write contract app is logger A, logger B, Solidity automatically drafts this exact lineup. First is app itself, second in line is logger A, third is logger B, and fourth is the implicit object base. This order is absolute law. It is the exact sequence in which implementations are going to be resolved. So the question becomes, how do we travel down this line without skipping anyone?
That brings us to Section 3, Super, the baton pass.
Okay, we need to completely rethink a keyword you've probably seen before. I want you to visualize super as the critical baton pass in a multi-inheritance relay race. And I really want you to burn this exact phrase into your memory. In Solidity, super does not mean call my parent. It means call the next contract in the linearization chain. This is, without a doubt, the single biggest misconception developers face. If you think super just looks directly up at a parent, multiple inheritance is always going to confuse you. It doesn't look up, it looks forward to the next person in that single file line we just mapped out.
Think of it exactly like a relay race. For the race to actually finish, every single runner has to do their part and then pass the baton. In code terms, this means every base function must be marked virtual, and crucially, it must call super. If logger A does its job but forgets to call super, it drops the baton. The race just ends right there. Logger B will stand there waiting forever, and its code will literally never execute. Hard-coding logger_a.init, like our buggy developer did earlier, was basically snatching the baton and running completely off the track.
Let's move on to Section 4, Fixing the broken chain.
So, we know exactly what's wrong, and we know the rules of the race. Now it's time to grab our engineering pens and fix the blueprint for our app contract. Look at the buggy code. logger_a.init. It is hard-coded, it's rigid, and it completely ignores that C3 lineup.
Now look at our elegant fix, super.unit. By using super, we are dynamically delegating the call to whoever happens to be next in line. We aren't naming names. We are just trusting the linearization process to hand the baton to the right contract.
But wait, the compiler is incredibly strict, remember? Even with the magic of super doing all this heavy lifting for the call routing, you still have to write out the explicit override list. You have to say override logger A, logger B. This essentially tells the compiler, yes, I know I am overriding these specific base contracts. Please allow me to manage the flow with super. It completely prevents accidental omissions and keeps your hierarchy crystal clear.
So, let's trace our newly fixed execution path. Step 1. App runs its init and calls super. Step 2. The baton passes to logger A since it's next in the C3 line. Logger A emits its event, and because it is a good team player, it also calls super. Step 3. The baton passes to logger B. It emits its event, and the race finishes successfully. Beautiful, right? Both events fire perfectly in sequence, exactly as we wanted.
Section 5. Constructors follow rules too.
Now listen, before you run off to build massive, complex contract hierarchies, let's pivot just a little bit. I need to warn you about a massive, silent edge case that trips up even the most experienced Web3 developers. We really need to talk about constructors. Constructor chaining and initialization side effects follow the exact same C3 linearization sequence. That lineup we drew earlier, app, then logger A, then logger B, that dictates the exact order in which your constructors are executed and their parameters are passed. If you are relying on a specific order for setting up state variables when your contract deploys, you absolutely must verify that your inheritance list matches your intended C3 order. Because if you put logger B before logger A in your inheritance declaration, their constructors will actually fire in reverse order.
All right, let's summarize the core engineering takeaways today so you can safely compose these complex contract blueprints. First takeaway, delegate, don't hardcode. Rely on super to traverse the chain instead of calling named parents directly. Second, make forwarding explicit with overrides. Always list your bases in the override clause so the compiler always has your back. And third, verify initialization order through testing. Because constructors follow the exact same linearized rules, the only way to be totally 100% sure is to write tests asserting the exact sequence of your deployment events.
Before we wrap up, I'm going to leave you with this provocative thought to ponder. What happens if a contract deep down in the chain, maybe even some third-party library you imported, forgets to call super? Well, if you've been following along today, you already know the answer. The baton drops, the chain breaks, and any contract standing in line behind it will be completely, entirely ignored. It's a pretty terrifying thought, honestly, which is exactly why understanding C3 linearization is what separates a novice from an absolute master. And that is it for this explainer. I highly recommend you head over to forge.college to dive deeper into this subject, play around with the code, and master even more Web3 engineering topics. This explainer was made by Forge College. Until next time, keep your chains unbroken and your code linearized.